Hi girls, so this video is about Simpson's rule. Simpson's rule is just like the trapezoidal rule in that it is another way to give approximate area under a curve. And it's especially useful either when integration is impossible or is difficult, and for whatever reason we only care about being close to the answer. Most of the time Simpson's rule is more accurate than trapezoidal rule, and in fact when it's a parabola it's perfectly accurate. It's actually exact answer, and you'd hope it'd be more accurate because if you look at the formula, which is here, and if you compare that to the trapezoidal rule formula, it's much more complicated. So I've just got the starting of a diagram here, and the reason it's exactly accurate when it's a parabola is because the way it works is effectively if the blue curve here is my function that I'm integrating, the red curve is actually the area that we are calculating using Simpson's rule. It's the area of a parabola, obviously with some conditions on its slope and things, that approximates fx as best it possibly can. And so that's why it's exact for a parabola. So the way the formula works is you divide it into three segments. Sometimes these things are called subintervals, but again I suspect that they will change the wording in all assessment tasks to mean applications, and what we've got here is one application of Simpson's rule. So obviously this value in the middle here is a plus b on 2. And so that would be one application of Simpson's rule. If I asked you to do two applications, what I would expect is instead you divide the interval up into sections like this with another cut in the middle there. And I'm not actually going to worry too much, but like this might be 1, 2, 3, 3, 4, and 5. So you might evaluate it at 1, 2, 3, 4, and 5. And in exactly the same way that the trapezoidal rule works, if I do two applications, the thing at the end on the first application will be the same as the thing at the start on the second application. So if you remember, the trapezoidal rule looks like FA plus FB times H on 2. And you end up with the pattern 1, 2, 2, 2, 2, 2, 2, 2, 2, 1 at the end. There's a similar kind of rule for this one that's certainly something you should absolutely commit to memory as soon as possible, and that the pattern is 1, 4, 2, 4, 2, 4, 1. Right? And the reason is, as I was trying to say before, that the number at the end will match the number at the start. So in this example that I've got here, this would be 1, 2, 3, 4, and 5 would actually have a 1 in it. So it'll have like one lot of F1, 4 lots of F2, 2 lots of F3, 4 lots of F4, and then 1 lot of F5. Okay? And so when we do, and I'm not actually going to do an example in this video, but when we do an example, we're going to set up a table, just like we have before. And our tables are going to look like this. Oh, sorry. Don't know what happened there. So our table's going to look like this. So you've got, so you've got X for your first column. So in the example we had, it might be 1, 2, 3, 4, and 5. And then you've got your Y or your Fx values, either or either. So F at 1 might be 7, F at 2 might be 4, F at 3 might be 5, and that might be 6, and it might be 12, or whatever it is. And then the third column is your pattern column. And for Simpson's rule, the pattern is 1, 4, 2, 4, 1. Right? If you end on 2, 1, it means you've made a mistake. You don't have the right number of points. And then in the bottom column, you multiply all these things together. Right? I'm multiplying Y times pattern. And then in the end you add them up. So what's that? 23, 33, 57, 69, and then you multiply that by, and the trick to remembering this is that the Simpsons have 3 kids, so you divide by 3, and you do 2 minus 1. And that would be your area. What would that be? 30, no, sorry, whoops, 23 units squared for that particular problem. Now I'm just going to go back and show you. See here, it's b minus a on 6. Right, in this example, b is the first, and b is the third, and a is the second, and there's a 1 in the middle. So if you take halfway through, instead of dividing by 6, you can now divide by 3, and that's why I've done it that way. Personally, I think it's better to remember it this way rather than remembering that formula, because then they're both, at the end, you take the difference between these two things and you divide them by something. Simpsons have 3 kids, so it's 3, and the trapezoidal rule happens to have 2. Okay? So expect a very detailed description of what that photo is on Monday, please. And I look forward to hearing your questions about the Simpsons rule. Thanks, girls.